Alrighty, so yesterday we talked about how we can solve systems of equations using a graph. And if they intersected in a single point, then there was one answer. If they were the same line, there were an infinite number of answers. And if the lines were parallel, there was no solution, right? So we're going to go through how to solve these by hand. Can you put it away, please? So steps for the substitution method. So this is the first method. So basically you want to solve one of your equations for either x or for y. And then you replace x or y in the other equation. Okay, so this very first one, we have y equals x minus 4, and x plus y equals negative 6. So we have solved the equation for y. Do you guys see how we have y equals x minus 4? So we're going to replace our y in the second equation with x minus 4. So we're going to have x plus x minus 4 equals negative 6. So we just plug it in there for the y. Okay, this now gives us an equation that only has x's. Eric, computer away, please. So we have 2x minus 4 equals negative 6. And we're going to add the 4 over. So we get 2x equals negative 2. So we end up with x equals negative 1. Oops, negative 1. So once you have the first variable, you need to find the second variable. So you can plug into any equation. So if you have isolated, like we did here, y equals x plus 4, that's the easy, or x minus 4. That's the easiest one to plug in for. So if we plug in our result into the y equals x minus 4, we have y equals negative 1 minus 4, so we get y equals negative 5. Okay, so what this represents is we had two lines that were intersecting, and they intersect in the point negative 1 comma negative 5. So that's our solution, and we always write it like a point like that. Okay. So the next one, looking at it, is there a variable that's easy to get by itself, x or y? Yeah, you can get the y by itself, or you can get the x by itself, right? It doesn't matter which one. Okay, so what if I solved for, let's say, x on this one, because then I just have to add the y to the other side. So we add the y over, and we end up getting y minus 4. Okay, so that means in the second equation, we would replace the x with what it's equal to. We're going to replace it with y minus 4. So then we have an equation that only has y's in it. Does that make sense? So we're trying to plug in. So we're going to have 3 times y minus 4 minus 2y equals negative 5, like that. So we only have y's. Now we're able to solve. Okay, so solve it out. So I have 3y minus 12 minus 2y equals negative 5. I'm going to combine my y's together. So I get y minus 12 equals negative 5. And then add the 12 over, so I get y equals 7. All right, so you should always be super careful on these problems. A lot of times people will mess up the first variable, like maybe they make a simple mistake here and put like y plus 12 or something. Then when they mess up that first variable, they mess up the second one as well. So be really careful with these. They can cause you lots of trouble on your homework if you mess up the first one. All right, so now that we have y equals 7, we go to any equation that we have. So once you've isolated, that's usually the easiest equation. So I have x equals y minus 4, and now you plug in. So you're like, okay, well, y was 7, so 7 minus 4 is going to be 3. And we write it in the order x comma y. So we have 3 first and then 7. Makes sense so far? You guys remember this? All right, so the next one has a fraction, so don't let that scare you. You can always multiply through by 2 to clear the fraction if you want. Or you could just solve for x. In this case, I think it's really easy to solve for x and leave the fraction in the problem. So if we do that, I would have x equals 3 over 2y and then minus 5 like that. Or not minus 5, plus 5. See, little mistakes can mess you up. All right, so now we go to our second equation, and we're going to replace the x with what we just found it was equal to. Right, x is equal to 3 over 2y plus 5, so I replace it. So I say 2 times 3 over 2y plus 5 minus 3y equals 8. We just continue to solve. So we're going to distribute our 2 in. So when we do that, we have 2 times 3 over 2 is 3, so we get 3y. 2 times 5 is 10. Minus 3y equals 8. You guys see that this one's a weird one? 3y minus 3y. It goes away. So we get 10 equals 8. So what situation is this? What's our answer? My answer is no answer, right? It's no solution, exactly. So we have no solution. So what does that mean about our lines? Yeah, that they're parallel. They're never going to intersect, right? So if I asked you on the homework, and I think I do this time, whether it's consistent, inconsistent, dependent, or independent, it would be inconsistent, right? Do you guys remember those words? So inconsistent. All right, so the next one. So steps to the elimination method. So sometimes we call this the addition and subtraction method. You can call it elimination, addition. It doesn't matter what you call them. Okay, but it's basically the one where you like line up your x's, line up your y's, and you add straight down. You guys remember those? So it says write both equations in standard form. So in other words, in the form ax plus by equals c. And then you multiply the terms of one or both the equations by constants so that the coefficients are opposite for one of the variables. So if you have like positive 3x, then you want to have negative 3x for the other one. So then when you add straight down, so it says line up the two equations and add straight down. So when you add straight down, one of those variables will be eliminated. So either x or y will go away if you did it correctly. Then plug in the number you found into either of the original equations and solve for the remaining variable. And then check your solution. So it's always good to check solutions. All right, so this first one, we have them lined up. We have the x's, we have the y's, we have the numbers. So think about it. If I add straight down, I'd have 2x. If I add my y straight down, what do I get? 0. That's what we want. We want to eliminate one of the variables. That's why it's called elimination, right? So we're going to add straight down. And when I do that, I get 2x, right? X plus x is 2x. But the negative y plus y is going to go away. That's completely gone. Okay, so you can put plus 0 or just leave it off. And then equals 10. So right away, we have what x is equal to. 2x equals 10, so that means x equals 5. And then it's just like substitution from here. So we look for either equation, so any equation that has x and y in it. So let's say I do x plus y equals 7. Let's say we do that one. Doesn't matter which one. Then I'm going to replace. I'm going to say, well, x was 5, so 5 plus y equals 7, so that means y is 2. So our answer then is 5, 2. That would be the point where those two lines intersect. All right, easy enough? So what do you guys notice about the next one? Look at your x's, look at your y's, yeah?
Do you want us to write it in a...
Yeah, write them as a point.
Right.
Actually saves me a lot of, I like to brag that I'm the fastest grader in the school, but I'm the fastest grader in the school because I make you guys do things like that. Like I'm very particular. So it's very quick for me to grade. If I see x, y, I don't have to search for all your answers. I do grade very fast. I knew your grade by the end of the day yesterday, didn't I? Oh, yes. Yeah, a lot of math teachers don't grade very fast. I don't know. It's like a photographic memory something. I don't know. I just memorize all the numbers on the page. It's kind of freaky. So I don't know. It's weird. All right. So anyway, so I have x's and I have y. So if I add them straight down, do you guys see how you would have 5x? And if you add straight down, you have 8y. 5x plus 8y equals negative 25. Doesn't help us. That's just another equation that has both x and y. Okay, do you guys see what I'm getting at? So we need for them to be opposite each other so that they're going to cancel. And it doesn't matter which variables you choose. So let's pick the ones that give a smaller output. So let's pick the x's. So I'm going to multiply the top equation by 2. And I'm going to multiply the bottom equation by 3. But I'm going to make it negative. So some teachers like for them to be the same thing and then they just subtract each equation, but I find that really confusing for students because they forget to subtract then. They mess up with the signs. So I just do it all at once. So when I do that, I get 6x plus 10y equals negative 32. And I have negative 6x minus 9y equals positive 27. So I multiplied the 2 into everything, and I multiplied the negative 3 into everything. So notice how I multiplied on this side of the equation too. So on the right side as well. Remember, I'm keeping those equations balanced.
Does it matter if you like add or subtract?
It doesn't. I usually make it so that they're opposite signs so I can just add straight down. Okay, and that's just, in my years of teaching, it's just easier for students to do that way. Because if they left it as a negative, like if they had 6x plus 10y equals negative 32, and then I guess this was positive. I don't know, I said left as a negative. And then they subtract. then a lot of people will write 19y here because they'll forget that they're subtracting out this entire equation, right? So it's just easier to have the signs right there for you. All right, so when we add straight down, the x's go away. We get y equals -5. So we have y. So then we go to any equation. So let's say I go to the 3x plus 5y equals -16. And we replace our y with what it was equal to. So I have 3x plus 5 times -5 equals -16. So I have 3x minus 25 equals -16. And I add the 25 over. So I get, oh, whoops, not 9. Yeah, 9, right? Yeah. All right, and then I'm going to divide by 3. And I get x equals 3. So our final answer is 3 for x, -5 for y. So write it in the order that it is, right? X, comma, y. Done. Okay, is this easy? You guys feeling good about this? Yeah, it's pretty easy. I know, you want to, huh? All right, so the next one. So I'm going to multiply through by 2. Why did I choose 2? Yeah, because then those y's cancel, right? So you could have done it another way. You could have multiplied the top by 3 and the bottom by -5, and the x's would go away. But I try to do the least multiplication steps possible, right? So if you could just multiply by 2, you can get rid of the y's. So we have 10x minus 4y equals 38. And then I have 3x plus 4y equals 1. So when I add straight down, my y's go away. I get 13x equals 39. So x equals 3. And then I plug into any equation. So let's say I plug into 3x plus 4y equals 1. So I have 3 times 3 plus 4 times y equals 1. So I have 9 plus 4y equals 1. Subtract the 9 over, I get -8. So y is then -2. So our answer is 3, -2. All right, so this is definitely like Algebra 1 type stuff. You did this in Algebra 1, hopefully. A lot of people make a lot of mistakes in Algebra 1, so hopefully you guys are a little bit more careful now that you've had 2 years of math since then. Well, 1 full year, I guess. So we could have some weird ones. So these are kind of weird ones. They're not like set up in the same, like x plus y equals number. So you got to move things around first. So let's say I move this one around and I get 4x plus 4y equals 5. So I added the 4y over. And then I have 2x plus 2y equals -1. So if I want to get rid of the x's, let's say, I'm going to multiply through by a -2. Do you guys already see that there's going to be something strange? Yeah, so I get -4x minus 4y equals +2. And then I have 4x plus 4y equals 5. So when you add straight down, x's and y's go away. So we have 0 on the left-hand side. Equals 7. Is 0 equal to 7? No. So we write no solution. What if I had gotten 0 equals 0? Then that would be infinitely many solutions, right? And we say it that way. We don't say all real numbers because like every point for x and y doesn't work. But it would be an infinite number of answers. All right, or you could have things that have fractions. Those of you that have fraction phobia don't like this. It's okay, power through, we can do this. So we have 4 and 3 for our denominators for the first one. So I would just go ahead and clear because sometimes working with fractions is a little hard. So let's go ahead and multiply through by 12. I don't think it's hard. I like fractions. All right, multiply through. So when I multiply by 12, I'm going to have 12 times 3/4. So that's when you can kind of write things off to the side if you need to, or you can think 12 over 1 times 3 over 4. You get 36 over 4. 36 divided by 4 is 9, right? Or you could reduce, remember. And you get 9. So we have 9x plus, can you guys do the next one? It's 8 because the 12 and 3 reduced to 4. And you can also think of it this way, 2/3 of 12. Break 12 into 3 pieces, right? If 12 is in 3 pieces, each piece is 4, and then take 2 of those pieces. So 2 times 4 is 8. So I have 8y equals, Who knows their times tables? Ah, good. Some schools don't have you memorize up to 12. I think that's weird. All right, so the next one. So all we're doing is we're just clearing fractions right now. We're not worried about getting things to be the same. So let's multiply through by 10. So when we do that, we have 10 times 3/5. So we get 6x minus 5y equals 180. So if we add straight down now, nothing's going to happen, right? We're still going to have an equation that has x and has y. Okay, so we want to get our x's and y's to be the same. X's or y's to be the same. So it doesn't matter. Which one do you guys want to change? Y. So if we change y, it's going to go up to 40. If we change x, it would be, can we make it smaller than 40? 18. You could make it 18. So I would do the x's. I make them as small as possible. So you can do either one. So let's multiply by 2, and then let's multiply this one by -3. So we're going to have 18x plus 16y equals 2 times 84. And I get negative 18x plus 15y equals negative 540. And we add straight down. So we get 31y. And we have 168 minus 540. Do you guys know that? It's what? Oh, whoops, I forgot to carry. I know I'm not very speedy. Negative 372. And then when we divide by y, all right, help me out here. What is it? Is it 12? I think it's 12. Negative 12. All right. So we have y equals negative 12, and then we go back to any equation. So you could even go back to the fraction equations if you want to. I'm probably going to go back to these ones up here. So I'm going to go back to one like that. So let's say I have 6x, because it can be any equation with x and y. It doesn't matter. It doesn't have to be the original or anything. So 6x minus 5y equals 180. So I have 6x minus 5 times negative 12 equals 180. So I have 6x plus 5 times 12 is 60 equals 180. I subtract my 60 over, so I get 120, and then I divide. So I get x equals 20. So your solution is 20 comma negative 12. So sometimes they aren't as easy. That is a tricky one, isn't it? Definitely an Algebra 2 type 1. All right, and then, of course, you can have story problems and so on that involve systems of equations. We're going to do a lot of story problems with systems of inequalities, but we'll do a couple of these. So it says, last year the soccer team paid $5 per pair of socks, $17 per pair of shorts. I feel like that's cheap for both of those. For a total of $315. This year they spent $342 to buy the same number of pairs of socks and shorts because the socks now cost $6 a pair and the shorts cost $18. All right, write a system of 2 equations that represents the number of pairs of socks and shorts, y, bought each year. So x is our number of pairs of socks. So the first year we spent $5 for each pair of socks. And for each pair of shorts, we spent $17. And that total amount of money we spent was $315. All right, but now socks are $6 a pair, and shorts are $18 a pair. And now we're spending $342. So are we able to figure out the number of pairs of socks and number of pairs of shorts? All right, so I would not change the y's, right? Do you guys see why we're not going to do the y's? You'd have to multiply by 18 and 17. That'd be big, right? So let's multiply this and this. The top one by 6. The bottom by -5. Yep. So we're going to make them so they will line up and are opposite each other. All right, so help me out with some multiplication here. Let me get my calculator out, I guess. So, oh yes, I could do that one. Thank you. 30x plus, what was it? It should end in a 2. Let's see, 102. Y equals and 90. Okay. And then I multiply through by -5, so I have -30x minus 90y equals, what's this one? Okay, say it louder. What is it? And 10? Okay. And then we add straight down. Oh, I guess I was just supposed to write the equation, wasn't I? That's okay. We'll go down here. It says write a system of two equations. This was the system of two equations. All right, and then we solve. So we get 12y equals, add straight down, so subtract. So what do we get? 180. So y equals 15, I believe, right? Did we get that? All right, so y is 15. Go back to any equation. So let's say I go back to 5x plus 17y equals 315, and I plug in y. So I have 5x plus 17 times 15 equals 315. What's 17 times 15? 255. We subtract it over. What do we get when we subtract it over? 60. So x equals 12. So those were some pretty big numbers. Now there is one way that you could have made this easier. All right, sometimes if you guys notice, like this equation right here, all of those numbers are all divisible by 6. So that would have made it a little bit easier, because what we could do is we could divide out by 6. If I divide by 6, then I'd have x plus 3y equals, I don't know, what's 342 divided by 6? Help me out. Huh? 342 divided by 6? 57. Okay, then we'd have that equation, and we'd have the 5x plus 17y equals 315. And then you could just multiply by -5, and then you get them to be opposite. Does that make sense? So sometimes if you can reduce an equation, you don't have to go as big with your numbers. Okay, so you could have made it a little bit easier.
Or you could do the substitution.
Yeah, or you could like solve for one of them and do substitution, right? So especially when you had this, do you guys see what Jacob's saying? Like you could solve for x and say x equals 57 minus 3y and then plug it in. Substitution. All right, so Mr. Fitzgibbon is writing a test for his AP Euro class. The test will have true-false questions worth 2 points each, and multiple choice questions worth 4 points each, for a total of 100 points. He wants to have twice as many multiple choice questions as true-false. How many of each type of question should he have? Okay, so let's let x equal the number of true-false and y equal the number of multiple choice. So when we say he wants to have twice as many multiple choice questions as true-false, set up an equation for that. Twice as many multiple choice as true-false. So 2 times x has to equal the number of multiple choice, right? He wants to have double the number of true-false questions for his multiple choice questions. Do you guys see that? Okay, so twice as many multiple choice questions as his true-false questions. So I don't think it is, guys, right? So let's look at it. So I think so. I think it's 2x equals y. Am I right? Am I crazy? Okay. All right, let me explain. So twice as many multiple choice questions as true-false. So let's say he has 25 true-false. If he wants to have twice as many multiple choice questions, how much will he have? 50 multiple choice, right?
Yeah, I know, but you flipped it. Yeah, you flipped it.
What did I say? So 2x, 2 times the number of multiple choice, or true-false, equals the number of multiple choice. I think I'm right, guys.
Yeah.
Right? 2 times x, this is x, equals y. Right?
Yeah.
I'm right, I promise.
Yeah, all right.
All right, so 2x equals y. So you want to double the number that you have for x to get the number of y. I know what you guys are thinking, but it's not the way that the math is working, right? So you're saying twice multiple choice, but that's not what it is. Twice as many multiple choice questions as the true-false questions. The true-false is the less number. All right, so then as we do this, so the other question says the test will have true-false questions worth 2 points each and multiple choice questions worth 4 points each. So the true-false are each worth 2 points. So if our true false is x, we're going to have 2 times x plus 4 times y, and he wants to have a total of 100 points. All right, and then this would be easiest to solve with substitution. Do you guys see it? Because we already have solved for y, so we take this 2x and we replace our y with it. So we have 2x plus 4 times 2x equals 100. So we get 2x plus 8x equals 100. So I have 10x equals 100. So x equals 10. So he's going to have 10 true-false questions. And then he's going to have twice as many multiple choice questions as he has for true-false. So he has 10 true-false if he wants twice as many. So 20 multiple choice. All right, and that's our answer. So y equals 20. All right, makes sense? So we have lots of different questions there.